Thanks very much for having me here today. And I'm going to talk about underground observatories that have been developed in recent years in other parts of GB. So observatories are underground laboratories where we can look at processes, impacts in the physical, chemical and biological realms. And today I'm going to briefly talk about 3 observatories that have been developed looking at different types of geothermal energy. So on our diagram, we've already seen this diagram today. So we're going to look a bit at the Cardiff Geo-Observatory, which is looking at shallow aquifer geothermal. I'm going to mainly talk about the Glasgow Observatory, which is looking at mine water geothermal, because that's where I've been involved. And I'm also going to mention the Cheshire Observatory, which is looking at aquifer geothermal and energy storage. So I was going to talk a little bit about why these observatories are important. And on this slide, there are kind of 3 building blocks. And all of these building blocks kind of need to come together really for geothermal energy to become widespread. And so if we look at what they are, we need to have demonstrator and commercial schemes looking at geothermal energy that will prove the economic case, develop the markets and the supply chain, test the licensing and regulation. But we also need more research-based facilities to really understand the processes and impacts of geothermal energy in the subsurface and in the shallow subsurface. And so these are facilities for research and innovation, and what they will do will be hugely increase our evidence base on a number of different aspects of heat and heat storage. And they give something which you couldn't have in a commercial facility, which is flexibility for research. So it allows you, the observatory allows you to do different things with heat and flow, storing heat and so on, as Joseph gave a good example of in his project. The observatories we're developing also have a very comprehensive set of environmental data around them, and they're places where technology can be innovated. And taken together, those 2 aspects will allow the translation of the research work and commercial schemes into better informing policy, licensing and regulation, to looking at reducing the costs and risks of geothermal schemes, to working towards more social acceptance, raising the awareness of geothermal schemes and therefore the demand of geothermal schemes. And also, as we've seen in several presentations, looking at integration of systems of geothermal sources with other sources of heating and cooling. So first of all, I'm just going to talk about the Glasgow Observatory that I've been involved in developing. And this is an observatory looking at mine water heat and heat storage. So on the slide that I've got up now, I'm going to just give you a flavour of what's available at the Glasgow Observatory. So starting in the top left-hand corner in the sort of gold-coloured box. So a fundamental part of the Glasgow Observatory are 12 boreholes into the subsurface. And those are situated within fenced research compounds where people will be able to come and test their own equipment and do their own research. Going round in this slide, looking at the light blue box, a fundamental part of the observatory as well is that the downhole boreholes that you can see in this photograph, they have a lot of sensors on them. They have state-of-the-art sensors down the boreholes, within the boreholes. There's a lot of monitoring to really get a really good 4D picture of the subsurface, so really well characterized volumes of rock and fluids. The Glasgow Observatory is also doing quite a lot of stakeholder engagement and public engagement, and we saw earlier how important that is. We are also looking at the environmental baseline, so current environmental change in the water environment, the gas environment, the soil chemistry, for example, also in ground motion and seismic monitoring. And it's really important to get that baseline before we start doing geothermal activities so that we know what's happening in the environment anyway. And then finally, something we've also heard about earlier on today is the importance of open data and transparency in new geoenergy technologies. And so open data is a fundamental part of the observatories that are being developed. And that's both geological information, platform models, and so on. It's sort of static data packs, say, about the boreholes, and it's also coming on stream and available for some parts, such as Cardiff, is continuous and time series data, which is really important as well. So this is a picture here on this slide of the location of the Glasgow Observatory. And maybe what's very obvious when you look at it, it's in the urban area, it's in the east end of Glasgow. And that's a fundamental part of what we're trying to do, is place an observatory in a location where it's representative of the demand for heat. Heat doesn't travel particularly well, so it's important to do the research in places close to users to understand the real challenges in those areas. So the purple and green blobs on this diagram are where the boreholes are in our observatory. They're scattered across a site called Cunningar Loop on a meander in the River Clyde. And we've got boreholes in green that are mine water boreholes that target the mine workings, and then purple boreholes that are for the environmental baseline. And we have a deeper seismic monitoring borehole some distance away. And this is what our observatory looked like in the summer. It's not very exciting to look at because it's all under the ground. We will be putting on more surface monitoring equipment when we can get back onto site after COVID restrictions have lifted. But you can see that we have fenced research compounds. The boreholes are beneath manhole covers, and we will have a lot of monitoring equipment. And in each research compound, we have a number of boreholes to different depths. So we can look at the geology and the hydrogeology and subsurface change in both depth and in space. So just a few photographs here of what it's like to drill geothermal boreholes. This is a bit more visual. So obviously you have a fairly small, often drilling rig for shallow geothermal, such as this is. You install casing within that borehole when you've drilled it. In our case, this is an example of the casing with the screened interval, and this is one of our sensor cables going down the borehole, in this case to measure the geological properties down the borehole. And so what these boreholes target under the ground are coal mines in this case. So these two diagrams illustrate the boreholes that have been drilled down into the ground and the old coal mine workings. So there are 3 coal mine workings here, one here, the Glasgow Upper, the Glasgow L, and the Glasgow Main. And the boreholes target these different coal seams in the different locations. We have the sensor cables go down the boreholes, and we've obviously got the screened interval at the mine working, and we have hydrogeological data loggers within those boreholes to look at both the temperature down the hole, through the rock mass, and through time. And what that means for research, I'm just going to give one example here of an experiment that you could do for research that would look at the sustainability of the geothermal resource within the mine workings. So, for example, using our boreholes, you could pump from one of the boreholes. This is what the green arrow is showing. And then because you've got all the sensor equipment in the ground, you can look at what the response is, both in the rock mass and in adjacent boreholes, either boreholes that are shallower or boreholes that are in the same mine working but some distance away. And that will tell you how water's flowing through the subsurface, how connected the mine workings are, whether you're going to get a thermal breakthrough, how sustainable the resource is for how long, and so on. So those are the kind of experiments that you'd be able to do at the observatory. There's also a lot of opportunities to innovate new technologies at the observatories. So, for example, people might want to develop a new sensor. They might want to develop new ways of testing or treating water that would run through geothermal systems for tens of years. So it's important to look at the water chemistry and think about how that affects the components that you use in your system. So you might want to test out new components or new water treatment technologies. There'll be opportunities to look at the system in terms of the energy system and the heat transfer. And also the live data coming through gives big opportunities to look at the continuous sensor data and the interrelationships of different types of environmental data. So final slide on Glasgow. So we started drilling boreholes in Glasgow in 2018. Once COVID restrictions are lifted, the observatory will be open for researchers to come and use. But when we were drilling the boreholes, we provided samples to a number of different universities and had people visit on site and so on. And so there's already some early impact of giving out samples to universities and to people using the open data. So there's already PhD students using the data and some papers published in the topics such as the connectivity of the resource, the geothermal resource, geomechanics, how the rock mass behaves, and the response of the geomicrobiology. And those are all aspects which are important for the long-term resource sustainability of geothermal. So I'm going to move on briefly to talk about the Cardiff Urban Geoobservatory, and this is with colleagues based in Wales, such as Gareth Farr, David Boone, Ashley Patton, Johanna Scheidegger and Ryan Kendall. And the Cardiff Observatory is looking at shallow ground source heat potential in the superficial deposits. And what's really important about the Cardiff Observatory is the number of boreholes over a wide area across the city. So it's a city scale observatory for a city scale challenge in terms of heat supply. So there are many boreholes across the city, and there's temperature records down the boreholes. This is a picture of Gareth sampling or taking the temperature or dipping that borehole. There's a wide range of associated data, such as models and temperature data, in which you can see the effect of the urban heat island effect. There's a lot of information from the Cardiff Observatory on physical properties of the rock mass, and we heard earlier how important the thermal conductivity is. There's also an active scheme within Cardiff supplying heat to a nursery school, so there's a lot of data on heat pump use, and there's a hydrogeological model. So there's a lot of information there in Cardiff on shallow aquifer geothermal. And then finally, just a couple of slides on the Cheshire Observatory, which is led by my colleague Mike Spence and many colleagues in BGS. So the Cheshire Observatory is looking at aquifer geothermal, largely in the Sherwood sandstone, which we heard about earlier, also very important in Northern Ireland, and also energy storage. And the plans for the Cheshire Observatory are looking at arrays of boreholes. So this kind of 3D image shows just the number of boreholes in the Cheshire Observatory. And all of them have little cabinets next to them because they're very highly sensitive boreholes to look at the thermal response of these rocks and monitor those in 4D using a range of technologies. So this is a similar but plan view of those boreholes in the Cheshire Observatory that are planned to be drilled in 2021. So there's a range of boreholes for abstraction and reinjection. There are boreholes that have facility for multi-level sampling. There are some closed loop ground source heat boreholes, and there are boreholes for hydraulic and geophysical investigations. And there's a wide range of thermal research that will be able to be carried out at this array in Cheshire, looking at long-term effects of subsurface change and thermal perturbations, dispersion of heat, the degree of interaction between different boreholes, between heat change in different boreholes, and looking at the monitoring technologies for 4D imaging. And again, lots of opportunities for innovation of new techniques at this observatory. So finally, just to think through what all that means. So hopefully I've given an overview about how observatories can be used to de-risk through research. So by growing this sort of scientific evidence base at scaled observatories, monitored through time in unprecedented detail, we're going to gain a lot more knowledge about how to transfer heat sustainably and economically out of the subsurface and into the subsurface. The observatories also have a large amount of environmental and monitoring equipment, and that will enable us to monitor and manage wider impacts of subsurface change. And they're great places to innovate new technologies. And taken together, that hopefully will flow through to reduce uncertainties, costs, inform policy and regulation, raise awareness of geothermal, and improve public engagement. So if you have any more queries, there is a lot of information on the UK GEOS website with the address there, and yeah, please get back in touch with me. Thank you.